This video takes a look at the 5-number summary and how we can turn that 5-number summary into a box plot and a modified box plot. And the 5-number summary is just another numerical way of describing a set of data, and it really splits up our data into 5 useful data values. And from that we can tell kind of the range of the data, if data is concentrated to the left of the mean or to the left of the majority of the data or to the right, or if it looks symmetric, kind of like a normal distribution. So the first number that's in the 5-number summary is simply just the minimum value there. The second number is what's called quartile 1, and it's a number that defines the lowest 25% of the data, which is why it's called a quartile. And it's really the median of the lower half or the lower 50% of the data, which is a lot easier to find after you find the median, which is our third value of the 5-number summary. The fourth value, kind of similar to the second, is quartile 3, which defines where the end of the 75% lower is, or it divides the top 25%, so just like a quarter, 3/4 is 75%. It turns out to be really the median of the top half of the data, top 50%, and again, it's easier to find after you've found the median. And then our maximum value, or the fifth value, is the maximum value. Those 5 numbers make up the 5-number summary. And what we'll do is we'll calculate the 5-number summary on a set of data, a small set of data, and then turn that into a box plot, a graphical representation of the 5-number summary. So here's a set of data. It says a student did a study of how many items were purchased at a grocery store checkout from 2 p.m. to 3 p.m. Find the 5-number summary for the data. So first thing we would need to do, since we're calculating several different types of medians, is get our data ordered, which we already have. So it goes from 3 in increasing order up to 40 there. So to find our 5-number summary, well, the first number, obviously the easiest one, is the minimum. The minimum is 3. Then we can move down and find our maximum value, which turns out to be 40. From here, I like to find the median. The median on this set of data is we'll need to split up our data in half. So how many data values do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14 data points. So we'll need to find halfway between the 7th data point and the 8th data point, and that's going to be right here. The midpoint between 18 and 19 is 18.5, so that's our median. The next step is to take this lower half and find the median of this lower half. And since there are 7 data values here, our median is going to be a value, in this case 10, which splits up this lower half so that there's 3 numbers to the left of 10 and 3 numbers to the right of 10. That's our quartile 1. So quartile 1 is 10. And similarly, we want to do that for the upper half of the data, the upper 50%. So this value 28 here also splits up the top half so that there's 3 values to the left and 3 values to the right. So that's quartile 3, or 28 there. From here, we can now turn this 5-number summary into a box plot. So first step in a box plot is to create a horizontal number line, and I'll go from 0 to 40. That's the pretty much the range of our data. And start making what's called a box and a whisker plot. So I'll first start with using my minimum value and draw a little short vertical line at around 3 on my axis. I'll go up and draw a little bit longer line at 10, that quartile 1. Same length of line for my median at around 18.5, estimating it. At the quartile 3, 28, another long vertical line. And then at the far end, with my maximum, I'll do another little short line there. And from here I can create what's called the box and the whisker. So the first part is the little whisker. Draw a horizontal line from the minimum up to quartile 1. Now these 3 larger lines make up the box. So I'm going to draw a horizontal line on both top and bottom. and then finally draw another horizontal line for my right-hand whisker all the way out there. And what we can do is then label these 5 numbers on our box plot, just to show what the min, the max is, where our median is, and those 2 quartiles on it there. And again, why they call these quartiles is the bottom whisker part really is just 25% of your data, because that's the median, the middle of the lower half. The left-hand side of the box is the next 25%. The right-hand side of the box is 25%, and the right-hand whisker is also 25%. So there we have a nice way to represent what this data kind of looks like. And it can show us if any of these numbers are outliers here, possibly. It shows us if the data is skewed to one side, off to the left or off to the right. And when we do talk about outliers or unusually high or unusually small values, we need what's called the interquartile range. And what the interquartile range is really just the distance from Q1 up to Q3. So if we take Q3 minus Q1, in this case, this interquartile range would be 18. And we need that to do the second part of the video, which is optional, and it's looking at what's called a modified box plot. So if you're not doing a modified box plot, you can go ahead and turn off. If you want to look at what a modified box plot is, looking at how to identify outliers, continue on. So what's a modified box plot? A modified box plot indicates the outliers with a dot. So outliers just means an unusual value, unusually high or unusually low. So question is, what's an outlier? So it gets a little technical, but we'll explain what it is. So an outlier is any value that is further than 1.5 times the interquartile range, that IQR that we just saw from the first half of the video, from either Q1 or Q3. So what does that really mean? It means that an outlier X is any number less than 1.5 times that interquartile range, less than Q1, so less than that Q1. Or it could also be a number X that's greater than 1.5 times the IQR added to Q3. So to explain how this really works, let's look at another example, another data set. So here's another data set. It's not in order, but when we look at it, we can see that there could be some unusual values. We've got some small numbers here. 3 and 6 look kind of small compared to, your 20s, 30s, and 40s. Oh, we also have some larger numbers, maybe a 55 and a 61. So those look kind of large. So question is, are any of these numbers unusually small as opposed to are any of these numbers unusually large? So to figure that out, since we need to find our Q1, our median, and Q3, we need to get our data ordered so we can find those medians a lot easier. So one way to do it is to create our stem and leaf plot. So if I take just our raw data and look at our stem and leaf plot, there's what the leaves look like, but unfortunately they're not all in order, so I'll order those. And here's a nice stem and leaf plot that's ordered. From here, we can find our 5-number summary. And so let's see, what do we have? We've got 21 values in our data. So the median is going to be, it looks like the 11th value. And actually, let's start out with our minimum. That'll be the easiest one to do. So minimum is 3. We know the maximum is 61. Now if we want to find the median, as we were saying, it's the 11th number. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the 11th number looks like 31. So my median is 31. I've now split up my data into a lower half of 10 values and an upper half of 10 values. So to find the median of the lower half of the 10 values, it looks like it's going to be somewhere between the 5th value, looks like 19, and the 6th value, which is 22. So quartile 1 is going to be 19 plus the 22 divided by 2, so 20.5. And similarly for quartile 3, that's going to be halfway between the 32 and the 35, because that will be 5 above and 5 below. So that'll be the average of 32 and 35, which is 33.5. And there's my 5-number summary. So next is to figure out from this, what are the outliers? So our first step is to figure out what is that interquartile range between Q1 and Q3. So our interquartile range is simply just Q3, 33.5, minus Q1, 20.5. Looks like 13. So how do I figure out which values now are going to be unusually low as an outlier or unusually high? So an unusually low will be any number that is less than Q1 minus 1.5 times that interquartile range of 13. So that'll be 20.5 minus 1.5 times 13. So any number x less than 1 would be classified as an outlier. But looking at my data, I don't have any numbers less than 1. So we don't have any unusually small numbers. So even though we have a 3 and a 6, those technically are not unusually small. They're not outliers. So no small outliers. But to find the unusually large number for an outlier, x would be greater than Q3 plus 1.5 times the IQR. So that would be 33.5 plus 1.5 times the 13. This time we get x is greater than 52.5. So any number greater than 52.5 is an outlier. And it looks like we're going to have two of them. 55 and 61 are both outliers. So when we make our box plot, our modified box plot, we will want to denote these two outliers with a dot. And our box and whisker plot then will really go from the 3 up to 42 for our right-hand whisker, and these will be, the outliers will be dots. So let's take a look at that. Let me copy this data to a new page. And just like what we did before with our box plot, let's start out with our number line. So this time I'm going to go from 0 to 65. Let's mark down now our minimum value, our quartile 1, our quartile, or our, could call it quartile 2, but we call it the median, and then quartile 3. And let's do the whisker and the box next. So there's my box and my whisker. The right-hand whisker is going to go up to 42 because it's the largest value, not being an outlier. So a little line at 42 and my whisker, and then the two outliers will denote as dots. There we are. And again, we can label each of these values with what they actually are, just for a little bit better description on it there. So there's a modified box plot indicating that, yes, these two values here are classified as unusually high. They're the outliers, which will, in essence, skew both your standard deviation possibly and your mean a little bit to the right there. Good. So how do we get this on the calculator? Well, when we set up the stat plot on our calculator, so after you put the data into the stat editor and you go in to set up the stat plot, which we did when we wanted to calculate and graph a histogram, to make it do a box plot, we've got two options. The first option is a modified box plot, and the second option is just your regular box plot. So we can either do the modified or the regular box plot. If I do the regular box plot first, we'll get that long whisker going all the way out to the right, which doesn't indicate what the two outliers are. So to get the two outliers, let's select the modified box plot, and there we see the two outliers, which now this looks exactly like the box plot that we did by hand. So you've got both your regular and your modified box plot. So hopefully this will help you get an idea of how to calculate that 5-number summary and use it to either create a regular box plot, box and whisker plot, or a modified box plot.